So this is our presentation about sounds and lights. I'm Vanessa.
So,
So first we're gonna go over sound. So here are just some definitions. Periodic wave is a repetitive series of pulses, a wave sequence in which the particles of the medium undergo periodic motion. Wavelength is the distance between two identical points in consecutive cycles of a wave. Frequency is the number of waves produced per unit time, and the frequency is a reciprocal of the amount of time it takes for a single wavelength to pass a point. Period is the time required to complete one cycle of a wave. And nodes is the spot on the standing wave that does not move. The wave moves around it. And if you were to cut the wave in half along the wave, the intersections are the nodes. The antinode is where the wave is at its highest or lowest point. So on the images, you can see that the black points in the middle of the red and blue are the nodes, and then the red and the blue points are the antinodes. So wave addition, which is also known as wave interference, is a phenomenon in which two waves superpose to form a resultant wave of greater, lower, or the same amplitude. So in the picture below, you can see that two waves are coming together to make one big wave and then going back to make their own waves. So an example would be in noise canceling headphones. Many active headphones have an external microphone that screens incoming sounds, and when the microphone detects unwanted noise, such as the airplane engine, it sends a sound wave into the headphone speakers that is 180 degrees out of phase with a bothersome sound, and consequently the two waves cancel each other out, resulting in silence. So a standing wave is a stationary wave that doesn't move but oscillates in time with a peak amplitude profile that does not move in space. And a standing wave pattern is a vibrational pattern created within a medium when the vibrational frequency of the source causes reflected waves from one end of the medium to interfere with incident waves from the source. So for the physics interactive, we use the simple wave simulator, and some things that I noticed were that the bigger the wave, the bigger the wave amplitude, the higher the antinodes are, and the higher the frequency, the more waves created, and the lower the wave speed, the more stiff the wave becomes. And then from the wave addition simulator, the frequency affects the wavelength, and the periods become smaller and more close when V is altered. And then from the last simulator, the standing wave maker, I noticed that the higher wave speed, the more spread out the waves are. Higher frequency, the smaller the waves are, and the wave amplitude affects how high and low the nodes are.
Next is lights. A plane mirror. A plane mirror is a mirror with a flat reflective surface. The image is formed by a plane mirror is always a virtual image, and the law of reflection states that the incident ray, the reflected ray, and the normal ray to the surface of the mirror all lie in the same plane. An incident ray always equals the reflected ray. The reflected angle. A concave mirror is a curved mirror with a curved reflecting surface. As the object moves towards the mirror, the image location moves further away from the mirror, and the image size grows, but the image is still inverted. When the object is at the focal point, the image is at infinity. The rules of reflection: the angle between the incident ray and the normal is equal to the angle between the reflected ray and the normal ray. The incident ray, the normal ray, and the reflected ray are all in the same plane. Incident ray and refracted ray are on different sides of the normal, and the focal length is the distance between M and the concave mirror. A convex mirror is a curved mirror where the reflective surface bulges out towards the light source. The image on a convex mirror may appear real or virtual. A virtual image is one that you can only see if you look into the mirror. A real image is one that is projected out in front of the mirror. The image is behind the mirror, therefore when the object is far away from the mirror, the image is upright and located at the focal point. As the objects get closer, the image also approaches the mirror and grow until it equals the height of the object. Constructing a ray diagram will show what kind of image will be formed by a convex mirror. The physics interactive light, the plane mirror simulator. The light rays bounce off mirrors, and when light rays bounce off the mirror, they obey the law of reflection. Incident rays always equals the reflected angle. And to determine the image of an entire object, it is necessary to do a ray diagram on every single point on that object. In the concave simulator, it showed that when the object is far from the mirror, the image is inverted at the focal point, and the image appears inverted as the object moves further away. For the convex simulator, the image produced by a convex mirror is always virtual and located behind the mirror. When the object is far away from the mirror, the image is upright and located at the focal point.
Thank you.
Thank you.